Our next speaker, Russel Fraser, I mentioned him, and I hope everybody is sort of itching with your wallet to get out there. Trained as a metallurgist in Sydney and worked in forges, foundries, machine and heat treatment shops. He left the industry for a few years and then returned selling the equipment he previously used. After working for others for a while, Russel Fraser Sales, RFS, commenced in July 1993 with the aim of providing inspection, MDT and testing equipment to those assessing quality in the engineering, construction, aerospace, marine, NDT and diving industries. Many years of experience as a metallurgist in manufacturing and being involved in problem solving for customers for so many over the years has helped RFS to grow. Today he has a team of technical people, and I have used his resources and they are absolutely world class, surrounding him to help him solve problems with suitable equipment. Not only are we lucky enough to have Russ talking to us today, but he has brought a raft of gear, and he'll be available to do demonstrations over the next 2 days for anybody that's interested in any of that gear. So without further ado, if I may, I'll pass over to Russ and get him underway. But find your feed.
Well, I've got a lot to live up to after that introduction, haven't I? But no, it's always good. I always enjoy working with you guys. I got involved with IIMS because of our association with Cygnus Instruments, who have done a lot of work in conjunction with IIMS around the world over many years, and so we started off a few years ago doing a little exhibition at a show down in Sydney, and then we've done, I think I went up to Bali and then down on the James Craig a couple of years ago, and here I am again, and so it's all good fun. If I can get this thing to work. Come on, there we are. Right. You'll find what I've got to say a bit interesting coming from a person who's in sales, because I'm going to try and steer you towards a lot of lower cost options rather than a lot of higher cost options. There's many different ranges of non-destructive testing available. You're looking at surface defects, you're looking at internal defects, you're looking at places that you can't easily get into, and so often you need combinations of equipment, and there's always people there trying to sell you new equipment, and the new equipment they're trying to sell you has got a price tag which is way above what most marine surveyors can afford. Today you have this situation where knowledge is king. Everybody wants knowledge. They don't necessarily need the knowledge, but they want the knowledge because it's available. And so they will try to push you into using technologies that you don't really need to use, that are beyond what is required. And it's always important that before you start a job, you sort of get a scope as to what's wanted and why they want it, and is it suitable, and can you achieve what they want with what they're trying to do. There's lots of high cost options available. There's things like laser 3D scanning. If you come and talk to our Gary, he'll show you a piece of equipment that'll do wonderful things and give you great results for $120,000. And then you can come right down to things like pit gauges and other things that are there, boroscopes and infrared and ultrasonics and all of those things that are important, but this is the most important tool that you're going to have. Above all else, you need to use your eyes. People get there and there's a crack that you can just about fall over and break your ankle in. And they say, oh, we're going to have to test this with mag particle or penetrance to see if there's a crack. Well, there it is. Oh, stick your fingernail in it and try it, and it'll tell you what's there. And so we need to when people say, oh, why do we have to have our eyes tested? Well, it's important that we have our eyes tested because we need to be able to see things, and And so this, to me, is the most important tool of the lot. There's this, you probably, some might recognise this, it's now called 4 Rainbow. It used to be 4 Vanguard, and it's an FPSO, and you can have equipment like this, which is corrosion wheel probe inspection using phased array. And this gear here will set you back about $80,000, and what they do is you'll see that they've got the lines across there, and they scroll across with that roller probe, and they can stitch together patterns for the equipment which will show the corrosion on the inside of that flare knockout drum. Now that's good, but that's a lot of money. If you need it, you need it, and in this case they needed it, and so they did the work and got some great results, and the customer was happy, and the contractors made some good money out of it as well. But the other things you can have are things like laser 3D scanning. This is our Gary on an oil platform in the Bass Strait. I didn't have him working on a ship, but here he is on an oil platform in the Bass Strait, and this piece of equipment will scan the surface and will give you a corrosion map and give you a resolution down to about 40 microns of accuracy on the corrosion. You obviously got to, it's not X-ray equipment, so you've got to sandblast the surface off, because if you've got rust on the top, then the laser scanning is going to stop where the rust stops. But if you clean that back, you can do a work. I did a job down at Santos over in Port Beniathon when we first got this equipment a few years ago on behalf of one of our customers. We have a very strong line of demarcation. We don't do testing because our customers do testing. So if we do testing, we're in competition with them, and that's not good. You wouldn't want to find me out on a vessel doing some work that you should be doing and getting paid for. And I don't want to be there anyhow. But we did it on behalf of one of our inspection customers, and they got paid for the job, and it was on a 3-metre diameter skirt on a tower out at Port Beniathon. And I'm not quite sure why they really wanted it tested, because there was places where I could put my fist right through it. What they'd done is they built this tower, and they had 150 tonne of vessel above it, and they coated it in concrete round the scope. Before they coated it in concrete, they put insulation in there. And somewhere over the 25 years, water had got in, and you had warmth, and you had insulation, and then you had concrete, and they suddenly started to see rust stains coming out. So they pulled it all apart, and it was gruesome. And they wanted to do finite element analysis on it. But this is the sort of results that you can get. So you can actually produce a colour map which shows you exactly where the corrosion is and how deep it is depending upon the colour schemes. You can do other things on a pipe, or if you've got say you had a hull of a ship where somebody had knocked something into, you could actually measure the depth and do all sorts of analysis on it to analyse the mechanical damage that is part of it. For that, if you really need to, your best option is to go and employ somebody who's already got the gear and pay them to do it. They've got the training, they've got the expertise, they've spent the big bucks on the gear. You just pay them for what you want and you get the report. If you've got a lot of money and you really want a toy like that, we're more than happy to sell it to you. We're more than happy to do the training for you. But I understand that the sort of money that marine surveyors have got available to buy equipment is restricted, so we wouldn't be necessarily expecting you to do that. We come down to the simple things like ultrasonic thickness gauging. They've got 3 gauges out there, and they start from $600 and they go up to about $4,000, and there's more expensive ones if you want them. And all you're doing with that is, most of you are probably familiar with it, you've got a transmitting and a receiving probe, and the sound goes down, comes back. You know the velocity through steel is 5,920 metres a second. It times how long it takes for the signal to go down and back, divides it by 2, and then works out a thickness for you. That's good, except when you've got paint. or coatings, and sometimes these coatings seem to get thicker and thicker and thicker. And so Cygnus have a system where they actually measure through the coating, and I've been showing the guys out there this morning, and it actually disregards that first signal and starts measuring at the beginning of T2 and measures T2 and T3 to make sure that they're the same. And so therefore by doing that you don't need to grind the paint off before you do the result. Now once again, there's lots of options there to give you an inaccurate result. There's lots of tricks and traps, I had one of our customers up in North Queensland. He bought a nice new gauge. He went out to do a job and he rang me and he said, "This gauge is not working." He said, "I'm having trouble." He said, I can sometimes get readings, but then I can't get readings." And I said to him, "Well, what is the paint coating like?" I said, "Is it adherent or is it flaky?" He said, "Oh, it's a bit flaky in places." I said, "Well, there's part of your result, because if you've got an air gap between the paint and the metal hull of the vessel, sound doesn't travel through air very well. So therefore," I said, "you get there and scrape that off and then try it." So he came back about half an hour later and he said, "Oh yeah," he said, "I'm getting a lot better results." He said, "But I'm still getting a problem." He said, "I'm getting a result." He said, "And then I don't get a result. And then I get a thinner result, and then I don't get a result, and then I get a thicker result again." And I said to him, I said, "Wolf, is there any chance that you can get inside and have a look at the inside of this hull? Because to me, it sounds like what's happening is that your sound's coming off the inside of the hull, but you've got a deep pit. So as the sound, if I go back to, can I go back? No, wrong way. Now I'm in trouble. Oh well. I said, it sounds to me as though what's happening is that as the sound's coming down, it's coming back, and then when you get on the side of the pit, the sound is coming down, and instead of being reflected back at your probe, it's going off at an angle and you're losing it. When you get to the top of the pit, you're getting a signal, and when you go down the other side, the sound's going back. It's not coming back to your probe, and therefore you're not getting a result. Brings me back about 2 hours later. He said, "Have you seen the inside of this vessel, have you?" I said, "No." He said, "Well, exactly what you said is exactly what it's got." He said, "I've been doing this for many years." He said, "I've not seen a vessel with this much pitting depth on the inside of it." The good thing was he rang me back about 3 weeks later, and he said, "I've done 2 more full surveys since then." He said, "The gauge works fantastically." He said, it's just brilliant." I was up there visiting him a couple of years ago. He said, "If the Cygnus gauge is not available, I put the job off until..." He said, "We've got some other gauges." "I put the job off until I can get the gauge that I want to be able to do the job." And since then he's bought actually 2 more, so we're happy and he's happy. So when it comes to this, here's this guy at work. He's got one of the key tools as a chipping hammer there. I was just talking to one of our customers the other day, and he's doing some piles down in Port Kembla Harbour or Jarvis Bay, somewhere down there in the next week or so. And I said, "You got a good big chipping hammer?" He said, "Yeah, I have." He said, "Because what happens on the splash line, you get this build-up of corrosion, and it's really, really hard. And when you break it off, it almost looks like you smashed a piece of cast iron. You've got to actually flog that off to get rid of that, because sound won't go through it. And you get through that, and suddenly you'll get a thing." We had one of our customers a few years ago when they were building the nice, expensive apartments on the Finger Wharf in Woolloomooloo Bay there in Sydney. You know, it's this place where the apartments are all worth millions of dollars, and everybody that there has got a yacht or a luxury cruiser or 2. And they got halfway through building it, and somebody said, "Oh, we haven't done any inspection on the plate piles. Maybe we should inspect those to make sure they're okay." And so they went and they did it, and they did. They were all right, but you know, a thickness gauge and if I could get rid of this thing here. Next. There we are. So here's the side of a vessel being inspected with ultrasonics, and a lot of them they'll actually chalk out grids, and they'll put a grid line, a number in the grid, and you've got to go through and you've got to find the thinnest area in each of the respective grids. It's tedious, it's difficult, but it's the way it goes. If you don't inspect things, something like this happened in Sydney just a week ago, and if you look down in the bottom corner there, you can see the rust dribbling out from underneath the base plate, and that should have been, if anybody just walked through doing a visual inspection, should have been enough to say, well, hang on, I think we need to look at that. But yeah, so that pole collapsed, and that was on the Anzac Bridge in Sydney, and it just missed a cyclist apparently by metres who'd just ridden past, and this pole just came down. So it's the consequences of not doing it. And apparently over in Mike's part of the world, little dogs peeing on light poles is a massive problem for the power authorities, because of the fact that the poles rust and corrode, and they've got to be regularly checked. But yeah, that was just one that I just saw the other day, and I thought, oh yeah, that's a nice little bit of corrosion. With remote visual inspection or borescopes, you know, we need to be able to get down into places where we can't easily get inside pipes and things like that. And so, how to make this go back? Let's see if I can go back one. There we are. One of the other things that we had was one of our guys, and some of you probably had this, they had this beautiful pipes on this vessel that they were doing thickness gauging on, and they got to this section of pipe, and it was all nicely painted, and they were trying to do thickness gauging on it, and it would not, they couldn't get a result. They got their chipping hammer and hit it, and lo and behold, the paint came away, about 5 or 6 millimetres of rust fell to the floor around them, and here was this pipe that was almost completely corroded through, beautifully painted, looked perfect, but they'd just been painting over the rust, and then the rust had just kept on happening underneath. And so you know, there are little things like that you just need to think about in order to do it, because otherwise you can get badly caught. With our remote visual inspection, there's a couple of borescopes out there that you can have a look at, and they're great because the good thing about this sort of technology is that over the recent years, the quality of what you can do has gone up, and the price that you can get it for has come down. We've got a thing out there for just under 10 grand, which is you would normally pay $30,000-$40,000 for, and the quality and the performance is excellent, and it lets you get into places where you can't normally do. We just sold a couple to Royal Caribbean Cruise Lines a few weeks ago for inspecting their black water lines on a couple of their ships, and they're looking to put more of those in, and they've just been able to go at I think the units they bought were only about $3,000, and they're famously happy with the results that they're getting, and it's enabled them to get in and to do inspections in places where you know you can't do easily. And so borescopes are great. You can get units like this that have got a long cable that's got a 20-metre cable on that one, and it's actually got a feeder on it, and as you feed it out, the meter will read and show you how far down the line your probe is, so that makes it much easier for you to know what you're looking at. These are the sorts of resolution of some of the things that you can get with a borescope that's got a price tag of about $2,500, and so they're just things that let you get into places where you couldn't normally get. The other thing that's a important tool these days is your infrared thermography. Originally, infrared thermography, just a basic unit, was a box about this big with a cooler and a camera that was like a great big video camera, and they had all sorts of stuff happening And now, you know, I've got one out there which is the size of a mobile phone, and it's under $1,000. But with these things, this is the new one, the new pocket camera, and it's good for -10 degrees up to 150 degrees C, checking engines and bearings and cooling, radiators and you name it, looking for hot spots. You know, you can ignore a hot wire at your peril, and you end up with a result of something catching on fire, and maybe catching a lot of other things on fire as well. So there's applications there where you can actually connect and send by your mobile phone your results to anybody anywhere in the world and say, have a look at this, this is what the problem is, you know, what do you want to do about it? And then they can authorise what needs to happen. For doing vessels, looking for the blue spots or the cooler spots, so you're looking for water ingress inside a vessel, and you can have things like that. And there's a nice bit of moisture detection down the front there. Looking at switchboards and electrical connections. If they're getting hot like that and all the other ones are cold, then you know you've got a problem that needs to be looked at. And I think we've got an electrician here I was talking to earlier on today, and he's just open your switchboards and just go through the switchboard, and you can look and you can check to make sure that your connections are good. So it's a great tool, and it's one that just allows you to do a lot of things, but you need to understand the technology again. You can get reflections. I can shoot at a window up there and get a reflection of the thermal imprint from something up there. I can shoot at a concrete wall and I can get a reflection of something that's happening over the other side. And so you've got to be careful and understand how the technology works and what's happening. We sold one to a plumber who happens to be my neighbour across the road and 2 doors up. And he'd been talking to one of my guys, and he didn't know that it was my company, and he just knows me as Russell. He didn't think about my surname or anything like that. And he walked in, he said, "Oh, they let anybody in here." He said, "Oh, it's your company." I said, "Yeah, it's my company." "Oh, okay." So anyhow, we sold him this camera, and we then organised for him to go and get some training. And he was talking, he said, "I'm going to go down to Melbourne, I'm going to do my level 1 infrared technology course." He said, "This is fantastic." And he's up there, and he was just telling me the other day, he went into this place and he was able to find a leak that nobody else had been able to find, and where it came from. And so the householder said, "Well, seeing as you found the leak," he said, "I suppose you better do the plumbing job and fix it as well." And so he said, not only did I charge him to do that, he said, "But I then got a $2,500 plumbing job for fixing this thing and pulling this wall out and redoing all the piping and setting it all together." So he's pretty happy with all that. But you have to understand how the technology works in order to make sure you get it right. Because he said somebody else had come in and said, no, that's not where the leak was. He said, "And I'll stand on my judgment as to where it was." And when he got it apart, he proved to the householder that that's where it was, because he had the understanding as to how the equipment worked. And so often, the last thing that people do is to actually read the instruction book. I want to find out how things work, but no, we just go ahead and use it, but we don't find out. We don't take the time, and this is what Mike was talking about, the fact that you've got to have education, and there's so many things. I just had a guy bought a piece of gear just the other day, and one of my guys spent all day Tuesday with him and trained him on how to use the gear, and the guy just went away. He said, "Oh, this is fantastic." But you have to take the time to understand the technology. Ultrasonic listening. We normally hear to around about 20 kilohertz. Me with my tinnitus from forges and foundries and that, I come down a bit lower. But up around 40 kilohertz is a range where there's lots of sound can be emitted. Steam leaks, compressed air leaks, noisy bearings, electrical arcs and sparks. And Cygnus have developed a unit called Hatshaw, and the way they work with this is the thing with all the little round circles on it up there. That's a transmitter, and it's out there, and what they buy is a collapsible fishing rod, and you lower it down into the hold of the ship, turn it on remotely, listen, get a sound reading, close the hatch, and then go round the outside of the and this thing has got 19 transmitters, so it floods the whole thing with sound. And then you go around the outside of the hatch and listen, and if you can hear sound coming out above a certain level, then that's also a place where water can get in, and people are very upset when their cargo gets wet, and insurance companies hate it and owners hate it. And I was just saying, we had a ship down in Port Kembla Harbour some years ago, and it had a load of calcium carbonate on board that had got wet, and it got wet, and then it had gone solid, and they had to jackhammer it out of the hold of the ship. It wasn't very pretty. Come on. Doesn't want to go. Computers and me have a love-hate relationship. They love to hate me. So that's the way that the Hatshaw works. If you've got a leak, then the sound comes out, and you've got a unit, and you go around and do it. But we have another unit as well which works on the same sort of ultrasonic transmission, and that's one that comes from a company in the States, and it does the same thing. You have your headphones on and you can listen, and that unit that's depicted on there is a bit like the old mechanic's screwdriver that used to listen to the bearings. You'll just listen, and you can listen to a bearing that's making a noise, and if you can lubricate that bearing and the noise goes away, then you've solved the problem. If the noise is still there, then you know that it's only going to get worse. But you can have time, you can plot the sound on these things, and what happens is they'll get noisier and noisier and noisier, and then all of a sudden they'll go to failure. But if you can find it in the early stages, you can plan for maintenance before something breaks and then causes consequential damage elsewhere. We've just sold the first 6 of these to the Australian Navy, and after they'd done their training, they went on board one of the ships, and here was the guys going around checking the they have a little transmitter, and you put it on one side and you go around the watertight doors, and you can check and listen for where the sound's coming out to see where the seal is. Here they were checking the seals on the ovens in the galley. Here they were checking in a switchboard. Over in the UK some years ago, they had a few situations where the big power transformer stations, there was corona arcing inside there, and guys would open the door and go to walk in, and he got halfway between that source of high voltage and the earth, and the spark went bang, bang, fried the guy, killed him. And so now before they go into any of those installations, they go through, they can listen and they can hear corona arcing on the inside, and they know not to go in until such times as they've sorted out the problems that are there. Go back, and it's a simple solution, but it's one that will do it. Oh, with it, that one you don't work near a horse training track. There was a power station, and there was a railway line, and there was a horse training track, and they were getting all these funny noises. And they finally worked out that what it was is that as the horses were going around, if the horse broke wind in line with the thing, they were getting a perfect signature of a horse fart on the on the thing. And it took them about 2 days before they twigged as to why they were getting these noises, but that's what it was. So yeah, once again you've got to look to find out what the environment is. Pit gauges, simple things like a pit gauge. This is one here, and that's outside as well for you to have a look at, where you can actually, if you're up close to a wall, it's very hard with a small footed pit gauge to be able to get an accurate reading. And you can actually put extensions on these things so that you can you can get a larger area, so you can get a more representative indication as to what the surface is like, because you can say here's a pit, but if you've got a tiny little foot like this and you're trying to work out how deep the pit is and you can't get a reference back to the main area, then it's a problem. I always say to people, once again, use your eyes, because they'll be told, oh look, you've got to do this whole area, but if you can look at a whole area and the surface is perfect and there's one small area of corrosion, stand back, take a digital photo of it, and then do an assessment of the area where the specific corrosion is, rather than trying to do it and do something and say, well, what's the point? You can see with your eye that that's a good surface, so why go to all the work of doing it hard when you don't need to? There's our pit gauge, and you've got a simple little pit gauge. This one here is great. Yeah, people say, oh yeah, but it only gives you to a millimetre reading. Well, when you're looking at a corrosion pit, do you need anything better than that? This one's white, and you've got a hole in the corner of it, and it gets used by the divers. They take it down when they're diving because it's light, it's easy to use, it's easy to see, and it's stainless steel and perspex, so it doesn't corrode. We've got our little PG1. That thing's like $100, $99, and that's a great little unit. But once again, it's only got a small foot. But if you're only doing an isolated thing, that's fine. That's all you need. We've got a range of other things. There's fluorescent leak detection. So what you do is you can put a fluorescent dye into a water or into an oil. It won't damage the pumps or the engines. And then you go around with an ultraviolet light and you can look and you can see where the leak is, and you can work on it. We've got coating thickness gauges, there's vibration monitoring, and you can do that. There's vacuum leak detection. If you're doing something where there's been new welding on a plate, you can check to make sure that there's no holes going through on that. But this is the thing that's important, is to understand your equipment, and to understand. If you forget any of the other things I've talked about, this is the important thing. Understand your equipment and its capabilities. Training's important. You can get good results from an inexpensive piece of equipment. Should a salesman be saying that? Well, this one does. Because you can spend a lot of money, but you can do it with an inexpensive piece of gear, and you can get all the information that you want. And there's got to be a balance. You need to know who's responsible for the rules. Some people will ask you to do things, and you're looking to say, why on earth do they want me to do that? It's not relevant to what we're trying to achieve. And it's this thing with knowledge being king, and people just wanting knowledge for knowledge's sake. And I always say to people, best for you not to get involved in setting the rules. Let the person who's initiating the inspection, let them tell you what they want you to do, and then you do it. Because if you start and say, we'll do this and this and this, and then something goes pear-shaped, they'll come back and they'll put a gun at your head and say, see, it was all your fault because you did it wrong. Let them tell you what they want. Then if there's something that you think you need to add, well, that's all right. But don't do their job, because you just open yourself up for somebody firing holes at you. And then you need to know who's responsible for interpreting the results. I've seen people interpret results on a test that's been done, and one of my customers came to say, well, look, that's rubbish. I said, well, it is rubbish. I said, well, who did it? Oh, so-and-so. I said, well, what's his qualifications? Oh, he doesn't have any qualifications, but he was the one that they authorised to do the analysis of the results. I said, well, it's a lot of rubbish. You go back and contest that and get somebody who's qualified to interpret the results. because otherwise you can be, once again, in all sorts of doo-doo. If you can do this, then you can save the owners and the operators large sums of money from embarrassing failures at extremely inconvenient times. Well, I don't think there's ever a convenient time to have a failure. And so there's much more that's there that's available, but you need to analyse and find out what you need and what you can do. Thank you. Right on time.